And today we're excited to showcase Emerson's Cascade display featuring our latest innovation in package integrity testing. I'm Pat Laurie and I'm joined by Trent Riggs, who is going to share some insights into how this solution transforms quality control and ensures product safety. Thanks for joining us, Trent.
Thank you.
Now this looks a little bit different than the typical package integrity testing equipment that people are familiar with. Can you point out some of the key differences?
Sure. Package integrity testing really is a tool that helps producers identify leaks before they've left the production line. Many systems that are in use today rely on visual confirmation of leaks, and there are a couple of issues or potential issues with those. One is that they rely, so these visual confirmation are things like a person watching packages being sent through a water bath, or maybe cameras that are looking for the presence of a malformed seal. So in the case of a person watching a water bath, for example, you may not be able to do that at the full line speed. So that becomes a bottleneck, or you can only test samples of the product. With the camera system, some of the concerns or some of the issues we've seen there are some of these newer labels that are darker colored or multicolored. Cameras may have difficulty seeing the wrinkles and the leaks that are performed. There's also a potential issue. Many packages have sealing on multiple sides. Think of a pouch where it's sealed around the edges, and then maybe it has a fin seal along the back. This extra complexity really can make it challenging to identify leaks with some of their traditional tools.
So since you're not using vision technology, how does it detect leaks?
Yeah, Emerson's solution takes advantage of the fact that producers are filling their product with a modified atmosphere package or MAP. This replaces the air in the package with something that doesn't include oxygen. So nitrogen is a common one, carbon dioxide. So our tool here, our system here is basically sending packages through the sample chamber and then trying to detect the presence of carbon dioxide. And if the carbon dioxide is above the background levels, then that's an indicator that there's a leak in the package.
So what's the real value here for customers? I mean, nobody wants spoiled food, but do you have any data or numbers to back that up?
Yeah, hard numbers are difficult to use just because they're going to depend on the specifics of the product that's being tested. So instead of numbers, maybe it's better to just talk through the logic, and then people can apply the own costs of the product that they're working with. So the intent here is to catch a leak while it's still on the production line. And if you can do that, then that single sample is rejected and it can possibly be reused and processed again. If the leak isn't detected until it leaves the production line, so now you're in the shipping area, for example, you have a small leak and it soaks into the cardboard and it's visible from the outside. Well, now you're going to have to scrap that entire pallet's worth of material. None of that's going to be recycled and reused. It's going to be just pure scrap, and so your costs have gone up. If the leak isn't detected until it arrives at your customer, now you're going to have to deal with returns and the shipping, replacing that expired product or that bad product. And then if it happens too frequently, your customer may have some other concerns and it'll be a hit to your reputation. So it really kind of depends on where in the process that the leak is caught. And the goal here is to catch it before it leaves the production line.
Makes sense. So tell me, what types of products is this machine compatible with?
So the machine that we have here today is meant to work with things like dried or raw meats, shredded cheeses, pre-packaged breads, so a variety of consumer foods. We also have other versions of this that are for use with, say, carbonated beverages. So those wouldn't need a compression conveyor. There's also a system that's for use with aerosols. So we can work with a variety of types of containers, but this compression conveyor system specifically is for those foods that are in some sort of a tray with a cellophane seal or a plastic pouch or something like that.
I'm curious, how fast are the packages scanned?
We can actually inspect up to 200 packs per minute. So for most people, that's their full line speed and well above that.
Excellent. So now let's walk through the main parts of the system.
Great. Yeah, there are really two key parts. There's the compression conveyor itself, and then there's the analyzer tower. So inside the compression conveyor, you've got the area where the packs pass through, they're squeezed. On either side of that, we have some sample collection bars, and then at the output of the compression conveyor, there are some more sample collection bars. Those are constantly sending that air sample over to the analyzer for testing. The analyzer then, if it detects the presence of a leak, it sends a signal to the reject mechanism at the end of this module, and to allow that package to be discarded for later use. This conveyor system is intended to be slotted in immediately after that map fill process. And so as those packs come out of the map fill process, they enter the compression conveyor. There's an air knife that will kind of clean off any residual CO2 to ensure that you get a clean test sample as it passes through. Then over on the compression conveyor, over on the analyzer side, that really is a pump that is drawing the air through. There's the measurement cell that is actually making the measurement of whether or not carbon dioxide is present. And then there's the computer that's really displaying the ambient CO2 levels and identifying the presence of a leak and doing all the counting.
Thank you, Trent, for sharing your insights on Emerson's Cascade display and, of course, the advancements in package integrity testing. It's exciting to see how these solutions raise the bar for quality control and product safety. For those who want to dive deeper and explore how Emerson can support your specific needs, we encourage you to visit emerson.com. There you're going to find resources and ways to connect with our experts to discuss how we can help enhance your operations.